And I thought I would pick an off-the-wall one. Here's one, XeF5 cation. Okay, so what is the hybridization of xenon and XeF5 cation? If you're asked for the hybridization, you can determine what it is if you know how many electron groups there are around the center atom. Right? How many electron groups? So in order to get the number of electron groups, of course, you have to write the Lewis dot structure. And by now, you should be doing Lewis dot structures pretty fast and pretty accurately. But let's look at this one and see what we get. First of all, in order to get the Lewis dot structure, we talk about the topology. Xenon is less electronegative than fluorine, so it goes in the middle. And the fluorines go somewhere around the outside, like that. Now, if we add up the electrons, xenon has 8 valence electrons. Each fluorine has 7. So 8 plus 5 times 7 minus 1 for the cation. And that gave me 42. So I'll go ahead and put in the single bonds between the xenon and each one of the fluorines. And remember, this is a cation. And that's 10 electrons. So 42 minus 10 is 32. And each fluorine, in order to get its octet, needs 6. Six electrons per fluorine times 5 fluorines is 30 electrons. So we used 30, we had 32, we have 2 left over, 2 electrons left, and so they go on the xenon, right there. So this is the Lewis dot structure for the ion. Who could tell me what the shape class is of this ion? Anybody? AX5E. Excellent, excellent. AX5E. And how many electron groups are there? I hear 6, and I hear right. Okay, but I don't hear very many people saying 6. 1, 2, 3, 4, 5, 6. 6 electron groups. And therefore, what hybridization? SPD2? No, not quite. We need 6 hybrids. Still not right. That's only 5. D2, SP3, or if you prefer, SP3, D2, which I consider to be the same thing. So that's the hybridization of the xenon in this compound. You can see its shape over here. It's sort of a square pyramidal shape, but we covered all that back a ways.